This video is going to go over multiplying and dividing fractions. Let's start with multiplying fractions. To multiply two or more fractions together, we simply multiply across in the numerator and multiply across in the denominator. So multiply across the top, multiply across the bottom, then we simplify if possible. One thing to remember when you're multiplying or dividing fractions, it's the same rule for signs that we apply with multiplying or dividing integers. When we multiply like signs, positive times positive or negative times negative, we get a positive answer. When we multiply unlike signs, a positive times a negative, we get a negative answer. Same thing for division. If we divide a positive by a positive, or if we divide a negative by a negative, those like signs, same signs, we get a positive answer. If we take a positive number and divide it by a negative number, we get a negative answer, right? Positive fraction divided by negative fraction, which gives us a negative answer, a negative quotient. And then finally, remember a fraction is in lowest terms or simplest form when our numerator and denominator have no common factors other than 1. So let's look at this example. Multiply 3/7 times 4/9. We want to multiply across in the top and the bottom. So 3 times 4 is 12, 7 times 9 is 63. So we've multiplied the fractions and we get 12 divided by 63, sorry. But we still need to simplify if possible. So we need to say, is there a factor, a number that's in common with both 12 and 63? So we want to either find a number, which may be in our head. We think, okay, does 2 go into both of those numbers? No, because 63 is an odd number. Does 3 go into both of those? Ooh, maybe it does, right? So we might be able to find that factor without going through this prime factorization I'm going to explain here. But if you're not sure what number would go into both your top and bottom number, you can use this approach. You write each number as its product of primes. So the prime factorization means you break each number down into its product of prime factors and then simplify by canceling out common factors on top and bottom. So if we take 12, the prime factorization of 12 is 2 times 2 times 3. And the way that I get that is by taking my number and I make like a number tree and I think, give me 2 numbers that multiply into 12. I could do 6 times 2, I could do 3 times 4. Let's say I choose 3 times 4. It does not matter. 3 is a prime number because the only factors of 3 are 1 and 3. 4 is not prime because the factors of 4 are 1 and 4 and 2 and 2, right? So 4 is not prime. That means I can break it down further into its product of primes. And 2 times 2, of course, is 4, where 2 is a prime number. So 12 written as a product of primes is 2 times 2 times 3. And I could do the same thing with the number 63, break it down into its product of primes, 9 and 7. 7 is a prime number, so I circle that, and we don't go any further there. But 9 is a composite number. That means it's not a prime number because my factors of 9 are 1 and 9, but also 3 times 3 is 9, right? So 3 is also a factor of 9. So I have to break 9 down further, and 3 times 3 gives me 9. So I break that down, and 3 is prime. So we're done there, and 63 becomes 3 times 3 times 7. So now that I have it written as its product of primes on top and bottom, I notice I have a common 3 on top with the 3 on the bottom. I cancel one of those out, and what I'm left with is 2 times 2 on top and 3 times 7 on the bottom. 2 times 2 is 4. 3 times 7 is 21. And since we had positive times positive, we know our result should be positive, so we're good there. Now let's talk about dividing fractions. This can confuse a lot of students, but it's actually not too difficult if you remember the one golden rule of dividing fractions. The very first thing you do is flip that second fraction, and your problem becomes a multiplication problem. So it's pretty easy. You take that second fraction called the divisor, and you flip it So you make it the inverse, right? The reciprocal, and then the division becomes multiplication. Why? Because dividing by any number is the exact same thing as multiplying by its reciprocal, by multiplying by its flip. Once we do that and we have a multiplication problem, everything follows just like in the last example. So let's look at this one. Divide 3/4 by -7/4. Very first thing we do, flip that second fraction and the division becomes multiplication. Now we have 3/4 times -4/7. And if you're looking at signs here, you should know that your final answer should be negative because we have unlike signs here. We have a positive times a negative. So again, with dividing, we immediately flip that second fraction. The division problem became a multiplication problem. Now we multiply the numerators and we multiply the denominators. So I have 3 times -4, which is -12 on top. And on bottom we had 7 times 4, which is 28. So I have -12 over 28. And again, you could do a tree diagram, a tree breakdown to get your product of primes, which I've shown here. Or maybe you're thinking of the 12 and 28 and thinking, oh, I think 4 goes into both of those, right? So we also could find that common factor and divide both top and bottom by that common factor. So I could take -12 divided by 4 and get -3, and also take 28 divided by 4 and get the 7. So whether you do the product of primes or you find a common factor and divide both the top and bottom by that factor, either way we should get it down into -3/7. I hope this was helpful.